Hello students, in this class we shall discuss hysteresis. As I said in the previous class that there will be a complete class to make you understand what hysteresis is. So let us start. Suppose this is a solenoid. This is a typical solenoid. If you apply current from one side, it will enter and it will circulate like this and it will exit from the other end. So as you know, through the axis of the solenoid there is a magnetic field, very strong magnetic field. Okay, I think it is opposite in direction. Whatever, it is opposite in direction. Now if you insert some ferromagnetic material through this area, that is the space between inside the solenoid, if you insert a ferromagnetic material like iron, that iron will get magnetized obviously because it is placed on an existing magnetic field. So suppose the iron is like this. Okay, the iron is inserted like this and the coil is wound around that iron core. Okay. So now let us study what is the effect of this current on the magnetization of this field of this iron core. Okay, to study this we have to draw an axis like this. In this axis the independent quantity is the current entering into the solenoid, but here we shall not use current, instead we shall use intensity, magnetic field intensity, which is obviously directly proportional to current. More the current, more will be the intensity. And magnetization is obviously M, but we shall not use here M, we shall use instead B, that is amount of magnetic field produced by this core or iron. Okay, more the magnetization, more will be value of B. So now let us start. Suppose initially the current is there is no current. We shall start the current. We shall increase it from 0. If you increase it, the current will increase, and rapidly the magnetization also will increase. After some time, when all the domains of the ferromagnetic material are aligned in one direction, then there is no more domain to be aligned. Then it will get saturated. That means you can increase the current, but the magnetic field or the B value of the iron core is never going to increase again. So after some time it will get saturated like this. If you increase the current, it will continue like that. So we shall not go further in that direction. Let this point be O and this point be A. If you continue like this, it will go like this. Then after that, now the substance is magnetized well, current is high also. Now we shall reduce the current. If you reduce the current, it will never come again back like this. It will rather go like this, in this path. It will go like this. Okay, let this point be OA, so let it be B. Not B, these two are looking B, so let us denote these points as in small. So it is point B. Now here you look. Current is already 0, but magnetic field of the core is not 0. That means magnetization is not 0. That means some domains are still in that particular direction of external magnetic field. That means still they are not randomized yet. They possess the magnetic field they acquired. Okay, this value of B is called retentivity. Retentivity or remanence. Retentivity or remanence. Okay. This is the magnetic field by the core or magnetization by the core when the current is 0. Now already that means without any current the substance is already a magnet. To neutralize that amount of magnetic field, we have to increase the current in negative direction. So if you go like this, at this point it will be here. Okay, that means at this point current has acquired a negative value. That means current is now in this direction, but magnetic field has become 0 now. So this value of H is called coercivity. Coercivity, that is magnetic field intensity when magnetic field itself has become 0. Now if you continue the current, you continue increasing the current in that negative direction, then it will also go like this. Okay, it is too much. Actually this should be symmetrical, these two lines. Okay, it will be somehow like this. Now we have come, let this point be C and let this point be D. Now again, even if you increase the current in negative direction also, it will go like this because it is already saturated. Now no need to go in this direction. Again we shall increase the rather decrease the current in opposite direction. If you make it more positive, the curve will go like this. Again it will hit here. That means here again this value is equal to also this value. Okay, this is the retentivity in opposite direction. That means in the first case the magnetic field was in this direction. Now in this case it is in this direction. Now if you continue, finally it will go like this and it will come to the final point A. Now let this be point E, this one be F. Okay. Now one thing you mark here, initially we are increasing the current, magnetization is increasing, finally reaching at this point, decreasing the current, but it is not going in this path, it is going rather in this path. That means starting here, going in this path, in this path, in this path, finally coming in this. Now again if you come here, again it is not going to pass through this, again it will come like this. That means it will never come again or retrace this path OA. Okay, so this is now this is called hysteresis curve. Why hysteresis curve? Suppose at any particular point, at any particular moment, I want to know what is the magnetization of the material. If you want to know what is the magnetization of the material, suppose this point, okay, but if you increase the current, it is going to decrease or increase. I can't say how, because if it is at this point, if you increase the current, it is going like this. If it is at this point, if you increase the current, it is going like this. That means whether B is positive or negative, that will say what will be the next value of B. If B is positive, if you increase the current, it will decrease. If B is negative, if you increase the current, it will increase. That means it depends upon history. Initially, what the value of B was, it will decide what the value in future will be. That's why this is called hysteresis curve. Hysteresis curve. Okay. That means this is a cycle also. This is hysteresis cycle also. You can also call it hysteresis cycle. This cycle says that once a ferromagnetic material is magnetized, it will gain magnetization and lose magnetization in this format. Okay, that means it will never increase the magnetization or decrease the magnetization in linearly. That means increase or decrease will be always within a loop. Okay, that's why this is called hysteresis loop. And this relationship is between here B means magnetic field produced by the core, or the magnetic field produced by the magnetic moment inside the core. Okay, not the outside magnetic field. So if you increase the B value or magnetization, if you want to increase it, you have to increase the current. Okay, but if you increase the current, finally it will reach a saturation value. If you decrease current, it is never going to become zero immediately with the current or intensity. It will become zero if you give some extra current in negative direction. That current or H value is called coercivity. Okay, now what is retentivity? If you make a current zero after magnetizing it once, then it will not become zero immediately, rather it will retain some value when current is already zero. That value is called retentivity or remanence. Okay, so this property of the magnetic material or ferromagnetic material is very, very useful in some devices, and it also plays